Hi, my name's Clayton Warner, and I'm a automation installation manager of Wizard Retrofits, and I troubleshoot a lot of Wizard over the phones and stuff like that. Today, we're talking about Wizard PDS and how to maintenance your rails. This training is for operators and maintenance personnel that work on the Wizard tables. It's for pins not working, stuff like that. The understanding of design intent and maintenance requirements, and operating tips for the for your Wizard table. The purpose of Wizard PDS is to reduce your setup time on each truss. It allows more trusses to be out the door quicker, more linear feet per day. We went from 20, 30-minute setup of having to move manual pins to a 10 to 20-second setup of clicking a button in a computer and it runs the spots. But it's not going to run to the spots if they're not in the right calibration. In this video, or yes, in this presentation, should I say, we're going to be looking to show you calibration, show you why your pins aren't moving, what to check for when pins aren't moving, and things like that, and understanding the software of how to troubleshoot your system. Over the 17 years of Wizard being installed and everywhere around the country, we started off with Gen 1. That was from 2005 to 2009. The software you'll see is version 4.1.1, 2, 3, 4. It just depends. The steel stack inside of the boxes, it's your PLC. They are side by side in the box, but they're mounted on top of each other. The bottom one's your biggest PLC, and then you got two high-speed stackers and an I/O card. All of them run as one brain of that control box, and for each 4 rails of your table. So when if you got 48 rails, you're gonna have 20. You're gonna have 12 control boxes. Gen 1 right now we don't have the parts for it. We're upgrading that to Gen 3 as we go along. And yeah, so Gen 2, we got TIP software 2015 through 2018. I think there might even be 2014, 2013, but for the most part, we try to keep everybody. If we see it, we upgrade it to 2018 to it has more features, stuff like that. The stack inside of it, the PLC stack, is not side by side anymore. They are stacked on top of each other and are facing vertical. Again, the orientation is the bottom big card is your PLC. The 2 middle cards are your high-speed counters, and the top card is your I/O card. Gen 2 and Gen 3 can be on the same table. They can run as one, but they need to be on opposite ends. So Gen 2 needs to be, rails 1 through 20, and your Gen 3 needs to be 21 through 44. They can't be mixed into each other. Gen 3 was 2019, your software version of 2019, 2020, 8.11, 8.12. We're still doing bug fixes and stuff like that on 8.12, so you'll see 8.13, 8.14, just, every so often we'll be fixing certain things. Your PLCs in your Gen 3, there's 2 per box. Each one of them runs 2 rails, and you can communicate from your computer to each and every single box. For Gen 2 and Gen 1, there's a main PLC at the either left or right side of your line, wherever your main panel is at. That is the only thing that communicates to the computer. And that's kind of your Gen 1 to Gen 3 hardware PLC wise. On Wizard, the most common problems we see are pins are out of calibration. Guys call in, say their pins are out of calibration, and they're not lining up. What we do typically is run them through calibration, have them measure the pins. Most of the reason why they go out of calibration has to do with pin maybe that was out or was not working, and the guys will turn off a box and run the pins up with a speed wrench. That throws it out of calibration right away. The PLC is not on, and it's not counting. So that's why it gets out. Dropping lumber and tools on pins, that can, it can really put a big wreck on the pin. And it will move the pin out of calibration just ever so slightly, and if you do it so often, it'll continue to grow as far as calibration wise outside. And then one thing I've seen lately is ignoring camber. If you don't build with camber, if you have no idea what camber is, you probably want to have ignore camber selected. What it does is it runs kind of a arc in your board, your bottom cord and your top cord, and it'll run it at like at 3/16 per 10 foot or something like that. So you're going to see your bottom kind of start to climb up. As it climbs up, it's going to look like it's out of calibration. It's really not out of calibration. It is in calibration. It just shows it as you're trying to put camber in the truss. And that's some of the stuff we've seen lately. So when we start ignoring camber, everything goes back to normal, or where it should be, should I say. Understanding pin locations, the reason why we are able to move pins and know where the locations are at is if PLCs are receiving counts back from our encoders. And each PLC receives a count back, and it's ever so minimum, as far as counts, but you will see big difference in an eighth to a 16th off of your pin. If per se that PLC overcounts, it doesn't usually overcount. We have a 10 count range in there. When we have the 10 count range, if you were to shut off your box, that 10 counts could be in there. And as you do it more often, it could start to crawl out. So that's PLCs are what counts it. If the control boxes are off and the pins move manually, like I said earlier, it won't know where it's at. So you have to recalibrate with the box on. That's the only way you're able to recalibrate is with the box on. So any unpowered moves they're not picking up location. A lot of times PLCs will go to sleep in our Gen 3. There's a refresh procedure that I will discuss later. And then at the bottom there, you see a document with pin calibration. Click on that. It's a link you can go right to the source and read through this just a little bit further. So ignoring camber. In our Gen 2 software, there is a little check mark to hit for ignoring TPS camber. TPS camber comes from your engineering department putting together these trusses or designing these trusses. It's in most of MiTek software, so if it's not clicked to ignore it in there, you're going to see it on the table. In Gen 2, like I said, there's this check mark. In Gen 3, 2019, there's a check mark. In 2020 and newer, there is this camber source that you can pick if you want to have table camber, engineering camber, or no camber. Table camber is set by putting a camber amount and a camber span in. So the camber amount might be 3/16 per 10 foot. So you got to put 3, I believe it's 3, and the camber span at 120. And that'll put your camber in there the right way. And the way to get to this screen to check that is up in the upper left-hand corner. There's a black and white circle. In that black and white circle, there'll be configuration. Click on configuration, it brings up this screen, and then you can change the camber source. And in Gen 2, it's show configuration dialog. In there, you can change camber source. You got to click on tables on this dialog box. So to calibrate pins, again at the bottom, there's a link that can go a little bit further into this. To get to this screen, you got to go up to the upper left-hand corner, black and white circle on Gen 3. And in that menu of that black and white circle, there is pin calibration, configuration, all that stuff. Pin calibration is what you want to click on. There will be an error screen that pops up. You hit OK, and then it brings you to this screen. This is your 2020, 811, 812 calibration screen. 2019 looks different. 2018 looks different. 2018 is actually located at the bottom of your pin parking utility screen. But this is a screen you'll see in 2020 and 811 and 812. To calibrate a pin, you'll have to find the scribe line in your table. It's a cut mark on your table, and it could be about 3/16 wide. So pick which side you want to go on that, top or bottom, and use it every single place on the table. If you're doing rail 48, use the top of it. If you're doing rail 43, use the top of it. Always use the top or the bottom. Pick which one you want to use and use it. To measure you want to go from top of each pin. So the bottom pin, you want to go from top of it. From the top pin, you want to go from top of it. And measure down to that scribe line. And in this pin calibration, you want to select rail 1 and the top pin, or whatever rail you're working on. And if you measure the top pin first, you got to click on the top. You can see that that's blue on this screen here. That's how to select it. And you will go down to the bottom right individual calibration and put in there, say 284, and that's 2 feet 8 inches and 4/16. When you want to do the bottom one right below it, you'll click on the bottom and you'll highlight that one blue, and you go to the right and you click in that box and do, say, 184, and you'll hit set for each one. Set on top when you're done with the top, and then set on the bottom when you're done with the bottom. And that's how you calibrate one single pin at a time. Up in the upper right-hand corner is how you calibrate the entire, all the top pins and all the bottom pins. I do not suggest using it unless you have every single pin at 4 foot, 2 foot, and you know it's there, but the calibration maybe says it's not. Use the top then at that time and put in there 400 or 200. The drop down is next to the top there. That you have top and bottom in there. That's the way to gross calibrate it. Again, I don't suggest using it, because if you were to use it when you're trying to do one pin, you could recalibrate every top pin on the top table or top part of the table. Then you got to actually go and recalibrate every single pin. So don't suggest using it. It only shows up in admin mode. If you're not in admin mode, it will not be there. But if you want to use it, you need to get in admin mode if it's not there. For refreshing PLCs, again, we got to go with the admin mode. It's up in your upper left-hand corner, black and white circle. Hit enable admin mode. The password for your admin mode changes every day. So today it's 7/20/2023. It's gonna be 6 digits. You're gonna use the day backwards, so 02, the month backwards 70, and the year backwards 32. And that's your admin password for all MovePin software. Once you have it in admin mode, you can go to configuration then and get into PLCs. In PLCs, when you have a red PLC, it will be at the top, and it'll show you right at the top that it's not refreshing or it's not there. Sometimes these pins or PLCs just go to sleep. All they need is just a nice little quick refresh. Hit the refresh button. It should turn white and go back to where it is in line as far as its ID. Once it goes down there, exit out of the configuration screen and go and hit move pins again, and those pins that were not moving before should be moving now. If they don't refresh on the first one, give it a couple more clicks. Sometimes it just might be taking a little bit of time to read. The computer's reaching out to each PLC saying, "Hey, are you awake?" And it might take a little bit of time to wake them up. If after 4 or 5 clicks, if it doesn't seem like it's wanting to communicate, it's just the Cat5 cable could be bad going from it, or could be unplugged from that box. Go on the back side of the box, we have a Cat5 cable coming in on each corner. Some of them will have 2 Cat5 cables, some of them will have 1. The ones that have 1 are just jumping to the box next to it, either to the left or to the right, depending on where your 24-port switch is at. Go in, if it's got 2, then you know that one is going back to the switch. If it's got 1, then that one just daisy chains to the next box. Check to see that's plugged in, check to see if it's good. If you only have 2 PLCs down, then it's likely that box before it is communicating. So then the box next to it is the one that might be not communicating. So check your Cat5. That's kind of the main thing. Check Cat5 on the PLC. Why a pin isn't moving? If you've already checked your refresh PLC, could be quite a few things. One, is it have any obstruction in the rail? Is there any plates in there, nails, staples, anything like that? Could have got jammed up in the rail, could be stopping that slide nut. First thing I would do is grab the speed wrench and check to see if there's any resistance. If there is no resistance, then you should check your fuse and your your regen. Start with the fuse first, the easiest thing to check. You should have extra fuses around there. And if fuse appears to be good, seems like it's getting continuity, then check your regen. If the pin does not move when you're trying to move it with a speed wrench, if it seems like it's moving up a little bit but fighting back to the spot, it means that all the power and electrical is working correctly on there. Check your calibration at that point in time. Make sure that it's all calibrated good. Maybe it's not moving because it thinks it's in the spot it should be. If the pin is not even moving at all and you absolutely cannot move that slide nut, it could be because you have debris in the rail, obstruction in the rail, so check that, make sure it's cleaned out. One way to, or a nice little reference point is this link at the bottom of the writing here. It's a video on YouTube that kind of goes over everything to take a look at, inside of your control box, inside of your rail, stuff like that. So, and then one other thing you'll see is possibly that you're calibrating the pin, it moves, and the pin's moving 3 inches at a time, and it's not going to the right spot. It's because the encoder isn't counting right, and which might be either a cable or the encoder on your Gen 2, Gen 3 ER control boxes. ER stands for environmentally ready, so there's no fuses on the outside or anything like that. Everything's on the inside. In Gen 1, Gen 2 standard control boxes, you'll see fuses on the outside. Typically, those have big black plastic deals that the encoders and the motors plug into. That is all hardwired into your encoder, so really everything is all in one there. If you see that on your box that you have plastic ends, likely you need to replace the entire encoder and the cable. If you have metal ends and it's a yellow and a gray cord or yellow and a gray end, that is something that screws onto the encoder. The encoder cable screws on the encoder and screws into the control box. You need to check both the encoder and the encoder cable at this point. First, I would start with the encoder cord, check to see if it's tight to the control box, check to see if it's tight to the gearbox. If that appears to be tight, I would change out that encoder cord. It's the easiest thing to do. You should have a spare one that we send with each spare parts box, and plug it into the encoder, plug it in the gearbox or control box, and see if you have any movement. Then if it's moving at 3 inches at a time again still, then you need to swap out your encoder. Very rarely do you see a PLC make it do that, but at times the counts aren't getting through into the PLC. If you've swapped out the encoder cable, swapped out the encoder, swap PLC to the one to the right and see if it moves with the PLC at that point in time. If not, there could be some deeper issues, and I would say to call us. Lubricating rails. We use graphite, John Deere graphite. That's what we supply for each rail. It's what we recommend for each rail. In fact, I wouldn't even call it a recommendation. I would say you need to use this. Petroleum, paraffin-based oils and solvents like WD-40, kerosene, all that stuff, it gets gummed up. Reason why we know dry graphite works is we had a 4-rail table here way back in the day, and we ran each pin up and down the table, had a program set up to run each pin up and down the table, and dry graphite lasted the longest and was the best performing lubricant that we could put on our rails. So John Deere graphite, and to apply it, you use this wand, and in the next slides, we'll explain how to lubricate your table and why. After installation, during installation, after we're done installing your table, we will apply its first coat of graphite. What we recommend after that is every 2 weeks, you do another one for the first 3 months. And then after break-in, first 3 months you break in, do it once a month. And if you start to hear it's louder, it's time to graphite. When you graphite, it quiets down the pins quite a bit. They move a little bit smoother, and they'll start hitting locations better due to being lubricated. And you think about it, you got 2 metal pieces running up and down the table together, rubbing against each other. They start to wear out. If they got graphite lubricant in there, it's going to take a lot longer to wear them out. If it starts to gum up and you start seeing the rails start moving slower and taking a little bit tougher time to get through certain spots, that's due to too much graphite, or maybe not exercising the rails up and down the table after graphite lubrication. At that point, we recommend using carb cleaner to loosen up the graphite. You'll have to probably get a steel brush. You might even have to pull the entire rod out, get a steel brush and break out that stuff, and then reapply one small coat of graphite and send it back in there and let it run across it. Typically, we see that quite a bit if maybe it's one side of the truss and the pins never really make it up to past 5 or 6 foot. And you lubricate every month, while the top part's not getting that exercise. So in this next slide, we'll kind of talk about how to lubricate and exercise pins on the slide after this one. Before you start lubricating, you want to put all the pins down to 2 foot and 1 foot, and that's the entire table. Just get everything down there. In fact, at that point might be a really good time to calibrate the system as well and measure everything, get it all calibrated 2 foot, 1 foot. And then this is about the only time we ever say use the direction of up and down. And this is on Gen 3. You'll hit the up button, you'll put it top at 11 foot, bottom at 11 foot. That's going to move it up 11 feet from the spot it's at. So that's 2 foot, 1 foot. So you'll see the top go up to 13 foot and the bottom go up to 12 foot. As those pins are moving up the table, I would suggest having a broom handle, tape that wand to it and holding onto a can of graphite and running along those pins or along those rods. Those rods have to be moving to get the correct application onto the rails. So if you got one guy, do one rail at a time. If you got 2 guys, you could probably run 2 at a time because you're going to run through it pretty fast. And continuously spray lubricant up ahead of the slide nut, kind of the best way to do it. So if you stop at one point, you're going to put too much on there. Once that stuff dries, it's hard to get off. And then you move the pins back to the top of the table, and you'll just keep doing that down the table. Once you are kind of done, it'd be a good time to run the pins all the way up to the top and all the way back to the bottom a couple times to kind of spread out that graphite a little bit along the rails. Once it's dry, it's usually, those slide nuts will kind of move it around a little bit. And there's a document in the link below to go and look and further talk about this stuff. And have a few more pictures. For resources for this, obviously there's links for each one of our stuff we talked about today, but in the document at the top there you can find, or the online source at the top there, you can find a lot more documents and videos for Wizard and really all of our components. Down below, the second one there is your YouTube channel. You can find that in YouTube and find a lot more troubleshooting videos for Wizard, for, again, all of our components and stuff like that. So that's the end of our slide or our presentation. Thank you for watching, and hopefully you have more knowledge on your Wizard table. Thanks. Bye.